Aloha, Rich Halverson here. This is ICS321. Today is July 21st, and we're on about our 16th video. I looked at the calendar just the other day, and I guess according to the calendar, we're like 2/3 of the way through the class. Today, there's been some questions about the forum, and good questions. And so I have asked Brad, who is the leader of the forums, it's his thing, and he's here today, and he's gonna just explain some stuff, remind you about some deadlines, and answer any other questions that you may have. Okay, so take it away, Brad.
Hi, everybody. It's good to meet you. My name is Brad. I'm the TA this summer for the class. What I wanted to do was talk about briefly the forums. And really the whole goal of the forum for the database class this summer is to be a supplement to your core material, right? So your core material with databases are going to concern your SQL. A lot of the entry level type of jobs with databases, you need to know SQL, right? As you progress, if you decide to go into a career in databases, as you progress in your career, a lot of the database people become architects, right? So that's where the ER diagrams come into play, and you design these databases, right? But there's also a lot of mining and knowledge discovery with data, right? So really what my goal is for the forum is to broaden your horizons, right? A lot of this material that I'm going to talk about, you're going to find at the end of a database book, right? So it's usually graduate level type of material. And really my whole goal for you guys is just to present the material, broaden your horizons and connect the dots. Realize how everything is connected, okay? And really just encourage you guys to keep learning, right? Because it doesn't stop with your first database class, and it doesn't stop with just computer science. Technology evolves faster than most industries, right? And it drags the other, drags the other industries along with it. So no matter where you work or no matter where your career is, this is going to influence it, right? So it's really important information, and a lot of it talks about some stuff that might happen down the line in the future, 5 to 10 years down the line, perhaps. Right about the time when you guys hit your stride in terms of your career, when you graduate, right? You're going to be 5 to 10 years in. A lot of this stuff that I'm talking about right now is going to become more mainstream, right? So I'm really just trying to give you as much information to encourage you to keep learning, right? Because as people and as students and people that work in technology, you're learning all the time, right? It just doesn't stop when you graduate. So with that, what I'm going to do is share my screen and just talk about some of the topics that I have posted in the forum and really encourage you guys to post. So the requirements as per Lolima, and I sent out an email last night, you're going to post on at least 5 top topics. And my goal is to post around 10 topics, and I'll post some more in the next day or two. But you're going to respond to 5 topics. And it doesn't have to be a long response. Just my whole goal is to make you aware that these topics exist, right? And these are extensions to what you're, some of the material that you're trying to learn right now, okay? And these topics exist, and for you to connect them and know that they're out there. And if you want to learn more, just gives you an idea of where to find some of this information, right? You can always ask me questions. Feel free to send me an email. I'm going to type that in the chat. I'm not sure if they can see the chat or not on the recording. My email address is B as in Brad, J as in James, K as in Kite, 2608 at hawaii.edu. Okay. So feel free to email me with any questions, regarding if you plan on going to graduate school or if you're going to get a job, or it's just really good information. But respond to 5 topics, and I'll try to post at least 10, so you can pick them, pick and choose, and respond just with short responses. Just your thoughts on the area and some of the information that you might garner from looking it up online, right? It doesn't have to be a long essay, just a few sentences that respond to 5 of the topics that I post to, 5 of the 10, okay? So with that, I will share my screen, and we'll talk a little bit about the forum post. Me for a second while I bring it up. It's good to meet you guys, by the way. I encourage your study with databases. It's really the area that I gravitated towards in college. And the great thing about data is that no matter who you are, no matter what company you are, no matter what industry that you're in, all firms in every industry, in every economy, they all need to store and retrieve information, right? So there's really good job security with databases. Okay, if you get really good with SQL, whether it's PSQL, MySQL, all the variations, right? There's always going to be jobs out there, right? Because there's companies that need people to manage this data. Okay, so there's really good job security with it, and I encourage. And I'm biased, I guess, but I really like this area of computer science. Okay. So can everybody see my screen? Thumbs up. Dr. Halverson. Okay. Yeah, so this is just kind of a, these topics are kind of cool. When I posted, I TA'd for this class last summer too, and it was just kind of a creative endeavor. I didn't really know where I was going with this, but I wanted to give you guys a sense of what was on the horizon in terms of technology, right? It pays to anticipate things, right? If you can predict what's going to happen before it happens, it gives you a decided advantage, right? It gives you a big edge in life. If you can predict accurately what's going to happen before it happens, you have a huge edge, right? Huge edge in the competition. Now that's very difficult to do, right? It's not easy to predict the future. Many people have tried, a lot of people have failed, right? But if you can do it, it gives you a huge edge, right? So this is just an extension of a material that you're learning right now with databases and machine learning, data mining, and the quantum world too. There's a lot of hype right now in quantum, and we're probably decades away from a mainstream general purpose quantum computer. But a lot of the information theory and database stuff regarding quantum is really hot. And in 5 to 10 years, there's going to be an explosion of jobs, right? And so this just kind of gives you an idea of what's on the horizon. And if you want to go on to graduate school, master's, PhD, if you want to get jobs in industry, this is kind of the information that you're going to want to learn, right? So just kind of makes you aware that it's out there and encourages you to explore it a bit. So the Big Bang, data science, University of Hawaii's got a great data science program. A lot of schools are offering more and more data science programs. And within the last 5 years, there's been kind of an explosion of graduate programs that have come about in data science because it's really important. This just kind of gives you a clear and concise overview of data science. This paragraph here, really just very concise. And this is kind of the information, this is some of the information that you'll find at the end of your database book. For those of you ambitious souls that actually read to the end of the database book and understand fully what databases are and some of the graduate type of work that you could possibly do, this is what you'll find towards the end, okay? Machine learning, huge area right now. Companies, there's artificial intelligence everywhere, okay? No matter what company you work for, they all want to do this type of work. And here are some of the tools that you guys can use to implement some of the techniques that are discussed in the previous paragraph here, okay? So you have Python, you have Anaconda, you have TensorFlow. These things can be used in combination together. When you combine them, you can write code that implements these ideas here that I've highlighted. Okay? And it pays to explore these things, right? Just look them up online. There's tons of information. Whenever you're researching something, go right to the source, right? Go straight to the source. So go to tensorflow.org or whatever it's called, right? Go to python.org, go right to the source and start from a high level of abstraction, right? That's logical, right? It's logical to start from a high level of abstraction. What do I mean by that? Very general, right? And then once you get the general ideas down, then you can dive into the specifics, right? You refine that in the very specific topics, right? But it makes sense whenever you're beginning to learn something, it's logical to start at a high level of abstraction, right? And then drill down into it, into the specifics, okay? And go right to the source. So go to tensorflow.org or whatever the URL is, and python.org, right? Anaconda.com or .org, right? Go right to the source, pull as much information as you can, and figure out how these things can be combined. This just kind of gives you all science, every science classifies something, right? And all computer programming is just a simulation of the world as we see it, right? You can program a car driving, you can program a dog walking, right? You can program a plane flying, right? All computer programming is just a simulation of the world as we perceive it, right? So it pays to know about science, because at some point in your careers, you might have to program something, you might have to simulate a science, right? Whether it's forecasting rain, right? Or forecasting a hurricane or tsunami or tornado, or molecular diagrams, right? Forecasting those, or programming some thermodynamics, right? It's very possible in your career that you're going to have to simulate a science of some kind, whether it's a Wall Street diagram, financial, right? Sociology, economics, all these different sciences, you might have to simulate that via computer programming. So it pays to know about different sciences and how they're connected, right? There's usually a hierarchy, right? How they're built on top of each other, just like blocks, right? So this just kind of gives you an idea of science and how things are connected, and the different types of ideas that you may be asked to program one day. Right? And I included a great picture that I found about a year ago, and it really connected all the dots, right? And it just pays to take a look at it and to think about the picture and how everything's connected and built on top of each other, right? And then this just kind of gets into more research type of work. So for those of you brave souls that want to go on to master's and PhD, this just gives you an idea of what's on the horizon in terms of computing, right? It's been said that you can build a computer out of anything. Is that true or false? These are some of the scientists and some of the areas that are really hot right now, and just different types of computers that could potentially be built in the future, types of computers that you might work on one day. I don't know if they'll be in my lifetime, they may be, but certainly maybe in your lifetime or your children's lifetime. And a lot of companies are hiring for this type of thing right now too. So I will also post on security. There's data. So whenever you have data, there's always the challenge of securing that data, right? And I'm just going to post on a few top topics, right? Just to kind of make you aware of what's out there. Specifically with computer security, there's always cryptography, right? Network security, system security, and privacy. So those are the 4 topics that I'll be posting on. Just very general topics, right? This is a bachelor's type of class, and this is an intro to database. So this material is just meant to be as a supplement. If you go on to graduate school, there's going to be classes that really dive into this material, in depth, right? You're going to have professors that teach this material, and there's whole semesters and careers that are devoted to each particular part of what I'm talking about. I'm just exposing you to it, right? And it's up to you to decide whether you want to explore that or not, okay? So again, I think I posted 5 top topics here, and I'm going to post 5 more, 1, 2, 3, 4, 5. And you're required to make just a few sentences, like 2 or 3 sentence comments on them, and 5 topics, okay? And if you have any questions, please feel free to contact me. Any concerns, I'll do my best to answer. I may have to refresh my understanding of things, but I will get back to you as fast as I can. Again, my school email is B as in Brad, J as in James, K as in Kite, 2608@hawaii.edu. So please feel free to contact me. I'll do my best to respond back to you. Thanks for your time, guys.
All right, thanks a lot. So we can unshare this. So I'm going to share my screen now. Let's see. Where's my? Okay, let's try that again. I want to share that screen. number 3. Okay. All right. Okay. So thank you, Brad. That's excellent. Good guidance there. 5 topics, a couple thoughtful sentences each, at least a couple thoughtful sentences each. And really it's your participation that's going to get you all the points. Okay, so don't stress, no stress. I'm actually, I have a sort of a side interest in coming up with a full set of forum type questions that engage you that I can use in virtually any computer science class that I teach. So I have an ulterior motive, kind of a lofty motive, but this is really helping me out. So anyway, this is, I thought I'd take us to the syllabus here, and we are actually, this is, you know, we're July 21st, which is pretty late in the game here. We are, but today I'm gonna briefly, it's not a full class period. I'm gonna go over what you should learn and understand in transaction management, and we do a little bit of it in the projects. We actually, in stored procedure, the last stored procedure project is a transaction. You need to use the transaction instructions, so you'll learn that. But so let's get started here. A transaction is a sequence of database operations that must be completed or rejected as a whole. So there are many single instruction transactions, single statements transactions. Like any update is a transaction. It starts and it needs to finish completely before it is accepted. Something can happen along the way, like the disk head becomes faulty, or something breaks, and it has started, but it doesn't finish. It's up to the database to make sure that it rolls back and reports that the error occurred before the transaction started. So here's an example where they say, let's say you're going to transfer funds from one bank account to another, and the first operation removes the funds from the account, and the second operation deposits the $100 in another account. If the first transaction succeeds, but the second transaction fails, then the account holder is out $100. The first account holder is out $100. It's lost. The second account holder doesn't get it, and so that's an example of those two instructions need to be enclosed in the statements that define a transaction. So there's the concept here of when a transaction completes successfully is called a commit, and there's actually a commit statement when you're creating a transaction. You enclose the transaction in a transaction at the top and commit at the bottom, and if it makes it all the way through, then it knows that it didn't that some sort of exception did not occur, and then the commit statement commits it. Once it's committed, you cannot go backwards. Nothing will automatically make it go backwards. Now, if the transaction does not finish, and there's an error, then the database executes a rollback, which reverses any instruction that has taken place. It doesn't really reverse any instructions. It remembers the state of the database before the transaction began, and then if it doesn't make it all the way through and that commit statement is not executed, then the database just returns it to the state that it was before the transaction began. So here's some examples of circumstances which may cause a rollback. A magnetic disk fails. There's a conflict between two transactions where two airline customers attempt to reserve the same seat on a flight, for example. application detects an unsuccessful database operation, just like the one that the example up here. So, so this is a nice graphic on explaining the concept of commits and rollbacks, and you should click through this because clicking through this, of course, gets you all the points. Here we're doing the so let's keep it on. So here are transactions. You're moving data from one account, moving dollars from one account to another, and it seems to be successful. So you commit, and so it works. So the Sam Snead has got his extra $900, I guess, or whatever it is. And then here there's a rollback where you subtract $100, and Sam Snead subtract $100 from B, and something, okay, that happens. And there's a rollback, and it goes back to the way it was. Detects a failure, and then it has to restore. All right, so click through these. I did these already. How many transit statements must be in one? Okay, so anyway, when you finish clicking through all these, of course, you get all the points. How many SQL statements must be in a transaction? Well, you know, there can be more than one, as we've talked about, and a transaction can be a single statement too. So it would be at least one. After the transaction commits, it cannot be rolled back, so it would be never. And after a rollback, the database restarts a transaction. Not always. If it's a disk failure, it's not going to. But if it's something where two people try to reserve the same airline seat or something, it could do some sort of restart. Okay, this is the most important part of this chapter, the asset properties. If you ever talk about transactions, it's in the context of these 4 properties that all databases exhibit or possess. Transactions must be atomic, consistent, isolated, and durable, and these all mean something. Atomic means that either one or all, or either none or all of the operations are executed and applied to the database. No partial or incomplete results. Partial or incomplete results are rolled back. Okay, so that's what we were talking about before. Consistency means that whenever a transaction is committed, that all of the rules that you had for the database, which we've talked about earlier, you know, where referential integrity, you know, data fields being enforced, you know, the constraints on data fields being enforced, and even some triggers you may have to include in there to make sure that if you have any business rules, like you know, an employee never makes more than their boss, or it's just any kind of business rule like that. Consistent means when the operation is complete, when the atomic transaction is complete, the database, you know, all of the governing rules are still valid. So that's consistency.
Do you mind if I say something, Dr. Halverson?
Sure, please.
Okay, great. Yeah, I'll kind of be short. I don't want to take up too much time, but you know, on the topic of transactions too, if you decide to read further in your book beyond this class, transactions are fundamental in databases in that when you, there's also the topic of concurrency, right? So I think Dr. Halverson talked about it a little bit. There's this mechanism called a lock, right? And it kind of blocks one transaction from interfering with another transaction. And there's also recovery databases too. So whenever you work for a company or a big company, or a lot of times maybe even a college, they're always going to have a backup database, right? And so these are some topics with transactions. A lot of times the log files, I don't know if you guys ever have heard about log files, but the log files are going to be all the transactions that happen within a database are going to be logged. and they're going to be often sent to the backup database too. All right, so if there's a fire or something catastrophic happens with your primary database, then everything can be reverted to your backup, right? So all the transactions that happen are always logged. Those log files are shipped to a backup database, and it's usually someplace safe, right? Where there's no threat of fire or volcano or tornado, you know, it's going to be very safe. And just want to talk about that a little bit with transactions. So we have this idea of transactions are very fundamental to databases. There's this idea of concurrency control, and there's also an idea of recovery too. So if something happens to your database, all those transactions can be recovered. Those are going to be found in your backup database. And those are usually going to be shipped via log files. That's all I'll say. Thanks for the time, Dr. Hubbs.
Okay, very good. Very good. Thank you for that. So you actually touched on all these. Consistency is, as I said, all of the rules that applied before the transaction started apply afterwards. Transactions need to be isolated without interference from other transactions, and that's where scheduling and so on must take place. Computers usually process multiple transactions concurrently. So that's where if you have multiple processors, you have to make sure that there's no data conflict between them in a transaction. And a transaction is durable, and that's where this recovery thing comes in. That once it's saved in the database, once it happens, then it's permanently there. So if later on there is a catastrophic failure or something like that, then there is a recovery system which is used. Asset properties are supported in two database systems, which is what Brad was just talking about, and the recovery system enforces the atomic and the durable components of this properties of asset properties, and the concurrency system enforces the isolated transactions and consistency. All right, very good. So you can see that there. Here's a nice little exercise where we match the words with the descriptions, and I'll let you do those. The transaction withdraws. This is match the asset property with that's in violation. Is that like this one? No, it's either this one or this one. This is durable, isn't it? Okay. Anyway, so you can complete those. You get all the points when you're done. Of course, you can move them around, stick with it until you get it. All right, so here we're talking about this how we accomplish isolation, and so you want to read and understand these concepts: dirty read, non-repeatable read, phantom read, and here this illustrates them. Let's just quickly go through this for a. This is a dirty read where you upgrade a seat, you upgrade the seat, and you read, you upgrade a seat, you read the seat class, you write the ticket cost, and then it rolls back for some reason, and this commits. Okay, that's here is a non-repeatable read where T2 writes the ticket cost based on the economy seat T1. T1 is later upgrades the seat, and the passenger. So the passenger gets to ride first class. Let's say it upgrades it to first class, and so this is a non-repeatable read. And see, these are transactions which if they occur cannot. These are, if isolation is not enforced, then these things can happen. And that's what these are the three bad things that can happen. So if any of these bad things are happening, if you're detecting this as an error after a million transactions or whatever, you see some of these, then you know that there's an isolation problem. And here is another one of these matching. You can match these. You step through these. You figure out which one it is. You do it until you get it. And then database support for transactions extends to internal resources. Databases have no control over external resources, but it still has to. It still cannot have transactions that don't, or it still cannot have transactions which violate the asset properties. And so this is a this is a graphic that explains how that can happen. And here you're reserving a seat before the confirmation message is committed, the internet fails. So in here where you've actually sent the confirmation message and then there's a rollback. So this is an incorrect confirmation, and this is a failure to confirm to send the message. Here's a challenge activity. Now these are always a little bit more challenging because it's not the kind of thing where you can keep on trying until you get the right answer, like we can in participation activities. And if you get the wrong answer, you get a different question. So let's try to do one of these. There's two of them. I'm going to try to do the first one. Select. There's a chat question. Select the asset property violated. Okay, so transaction 1's updates account balance. Transaction 5 withdraws $5, and transaction 2 starts before 1 finishes. Okay, transaction 2, these need to be done in isolation sequentially one where I saw. So I'm going to say, oh, I got to click start. So I'm going to say isolation. Okay, transaction updates an account with a foreign key. The foreign key does not match any values. Oh, that would be a consistent. A transaction removes expired subscriptions, removes only half of them are written to the database due to system failure. That's a durable. A transaction updates all accounts on a balance set null to 0. Updates are written in the database, but due to a drive failure, the information is permanently lost. Okay, what did I not do? I didn't do atomic, did I? I'm going to say this. Oh, okay, so I got isolated should be the first one. Consistent, oh, durable and atomic. Okay, so I got durable and atomic wrong. The transaction removes only half the subscription. The transaction updates all accounts. Durable. Oh, but a drive failure. Okay, so that should have been my clue to durability. This should have been my clue to durability. To me, these are similar, but it wasn't this. This should have been atomic. Okay, so anyway, so we get a second chance here, and so let's try to get it again. What time is it? We got time. A transaction updates all accounts with a balance amount of 0. The updates are written to the database, but due to a drive failure. Okay, so that is durable, yeah. A transaction updates all accounts due to a system failure. Is that atomic? A transaction updates an account with a foreign key. That's consistent. 2 transactions run in parallel to set an account's balance to different values. That's isolation. Okay, very good. Okay, you can do the next one. All right, schedules. Okay, this is really the mathematical concurrency important part, operating systems kind of stuff where you're dealing with multiple processes, and you have to ensure that the ACID properties, that no ACID property is conflicts or is violated. So schedules, a transaction schedule is a sequential order of operations for multiple transactions. Operations for different transactions can be interleaved. So transactions can run concurrently. Operations for individual transactions must occur in the correct order. When a schedule, within a schedule, two operations in different transactions conflict when the relative order affects the outcome. See, so that's the important thing. You have to so here so you want you have to produce a schedule that where you can a set of schedules that are equivalent are valid. Conflicting ones contain the same transactions, but the order is not right. They're not interleaved the same way, which is what caused the conflict. So here we have a regular schedule where you read X, you set based on what you read, you set you calculate a new value for Y, and then you write it out, and then you commit it, and then you're going to do something different to Y, but Y but this is going to affect X. So the schedule is first this X. First X is updated. First X is read. The old X is used to update Z, and then after that, X is updated with the use of Y. Okay. So and that's because this first part, this T1 came first and T2 came second. Now what we want to do is we want to be able to interleave these for whatever reason, probably because it takes a long time to read stuff, and so if once we read, so we may want to since X is not used, it matters when they're used. So the reading of X has to be used. The reading of X and the usage of X has to be used. X has to be used in this formula in this one before it's used in this one. That's the only real rule here. Okay, and so that's why this one over here works. We're reading Y long before we're reading Y over here. In fact, we read Y before we read X. Really, what we can do is like read them at the same time because it takes a long time to read. We can initiate the reads at the same time, but we have to execute this statement. No, we have to execute. Oh, we have to execute this statement before we execute this statement. Okay, before we execute this one here, this X equals. So we have to use X before we change X. In this case, it doesn't work because here we update X before we use it. You see, we set X to a new value before we use it here, and so this is a conflicting schedule. This is going to give a different result than this. This will give the same result as the schedule. So that's the important point here. I'll refer to the schedules in the above animation. Refer to these schedules. Okay, so these are some questions and answers to test your understanding of this participation activity. So go through the participation activity and then try to answer these questions and see what's the first one. Read this, refer to the schedules above, use the initial values below for each question. Okay, after the schedule executes, what is the value of Z? Well, schedule. So that's this one. Okay, so we read X, and so X is 9, and then we divide 9 by 3 to get Z. Z is, we divide by, okay, so that's 3. 9 divided by 3 is 3. So Z becomes 3. So the answer is 3, he thinks. Very good. Okay, so you can do the rest of them. That's how you do them. Okay, here's another. So a serial schedule is a schedule which transactions are executed one at a time. So first T1 is executed when T1's all done, then T2 is executed. Serial schedules have no concurrent transactions. Any schedule that is equivalent to a serial schedule is a serializable schedule. So here's a second schedule here, and it turns out by the nature of the instructions that it is serializable. So that's a good way to test if your schedule is where you're not going to have any problems, like conflicting schedules. And so match the schedule type to the example schedule. So we have a serial schedule. Well, that would be, this is the serial schedule. We know that because it's, and then we have a non-serializable schedule and a serializable schedule. You can read X, X is updated. Read X, write X. Well, you're gonna have to look at this one and figure out what it is. Read X. These two are the same. Here we write X, and then we, oh, this one is serializable and this one isn't, because X is updated. X is updated and written, and then this X is written. So this reads X, the same X that it reads here, okay? Not this X, because this is in a different instruction stream. Okay, so I'm gonna say that, let's see, watch, I'll be wrong. I say this is I'm right. All right, so anyway, interesting. So relational databases allow administrators and applications programs to specify strict or relaxed levels of transaction. And so these are various levels of where it still needs to detect if things were committed properly, but you may have to roll back more often. So serializable transactions run in a serialized schedule with current transaction isolation is guaranteed. Repeatable read transactions, they only read committed data. So you don't have anything like you had up here. You don't have anything like this. Well, wait a minute. I'm not sure about that. Anyway, read committed transactions only commit. They also only read committed transactions, but after the transactions it reads it, then others can update the data. So here we just make sure that it's read only. It reads committed data, but but then after the reads are done, then it allows any updates to place before they're used. And then read uncommitted, can read uncommitted data. And read uncommitted processes concurrent transactions. It processes concurrent transactions efficiently, but allows for a broad range of isolation violations, which you have to deal with in some other way. So it's good to understand those, because if anything happens, you want to know what it is you might have to fix. And this is about recovery. Serializable schedules affect the concurrency system, which supports 3 additional scheduling types affect the recovery systems, which support atomic and durable operations. In a non-recoverable schedule, there's certain transactions may not be able to be rolled back. A cascading schedule, a rollback, if there's a rollback in a transaction, it may affect having to roll back other previous transactions, or perhaps other transactions that are in process. And for a strict schedule, a rollback of one transaction never means, or never affects having to roll back another transaction. So here, here's an example, this illustrates the 3 types. Strict schedule, it's all committed, and this, okay, so here's a cascading schedule where we're writing X, we read X, and then we end up having to roll back. See, so that means that this X is not, we need to put this back to the previous X, which affects the reading of X here. So then this has to be rolled back. Because something messed up on T1, T2 also has to be rolled back. But here for T1 and a non-recoverable, because X over here, it's the same as the cascading schedule, except for X is committed before T1 realizes it has to roll back. That's a problem, because once X is committed over here in T2, you're not able to roll back T1 because it would invalidate the value here. It would violate isolation, I guess. All right, here's another matching one. You can do that. Okay, here's what time is it? 11:23. We are on scheduling concurrency. Okay, so you should go through this. Let's try to see what's next here in the remaining 3 sections. Okay, concurrency. This talks about locks. Brad brought this up, and you should understand how these locks work. Fortunately, the most serious test you'll have in understanding this would be the challenge activities at the end, and there aren't any. Ah, good, you're lucky you. You just need to go through these participation exercises to make sure that you understand the role that locks play in concurrency. So if you are with databases, since you're writing statements and it's up to the database management system, the underlying database management system, to enforce all these things. If you are somebody who is working for Oracle and you're working on a newer, faster engine for whatever reason, maybe they've made a breakthrough in quantum computers and they're able to apply some of these new techniques you find in quantum computing, multiple universes and all that. And so you have to make sure that the ACID properties are still enforced. And so here, so this is the kind of reason why you'd have to learn. I mean, I'm sort of exaggerating, but this is not necessarily so important for the average database programmer to understand, because this is all taken care of for you. Where it becomes important is if there's a bug someplace or something is broken. There's a software error. There's an underlying software error, in the database management system you're using, and you discover something. You discover some of these concurrency problems. Let's say the locks are not working. It could be that the locking system that you're using is good for sparse transactions, but it's not good if there's a bunch of transactions that all want to happen at once. So that is also a reason where if the load of a system changes dramatically, you may want to consider going to a more relaxed or stricter locking system. So that's what this is about. And of course, this is the same stuff that applies in operating systems. So if you're taking the operating systems course, it's similar stuff. And then here's recovery. And it starts by talking about the failure scenarios and where things can fail. They can fail. It's usually some sort of mechanical thing or network thing, or something that happens outside the system, unless you're going with maybe a more relaxed scheduling or concurrency algorithms. So this talks about that. Here's an example of a system failure. What can happen with a system failure, and so you can step through this, see what they're trying to show you here, answer some questions about it. Here's talks about the recovery log and the types of recordings that it makes and what they're used, when they're used. So this is an example that you should step through, answer these questions, and then it talks about the recovery from these different kinds of failures that were listed above: recovery from system failure, and recovery from storage media failure, and this talks about the backups. Brad mentioned this a little bit. The last part of the section is on transactions, and so this is the now we're talking about what types of what's available in MySQL. And you notice that I've always stressed to use the INNODB storage engine and not the MyISAM storage engine. The default storage engine that you use if you're just creating a new table from nowhere in MySQL does not enforce these kinds of things. And so in this class, when we're doing these things, especially when we're writing stored procedures and so on, and you need to use this transaction statement, you want to make sure you're also the enforcement of foreign key constraints. You have to be using INNODB if you really want those things enforced. You can specify foreign keys and all that, but you can specify the enforcement or what should be enforced. But if you don't use the right storage engine, then those things won't be enforced. Generally you would use this storage engine when you're getting your database to work, and then once you're convinced that everything works right, then you can switch over to a different storage engine that doesn't necessarily enforce those things, but can be quite a bit faster. That's transactions, and we are at the end of we're at the end of this chapter. So make sure you go through this, and you'll experience it in the last assignment. So next time, the last class for this week, I'm gonna cover chapter 7, and this is maybe more interesting, the chapter 7, because we talk about the different storage media and things that you might have to know and understand about. Let's say if you're buying a new laptop or any kind of computer, actually physically how magnetic disks work and flash memory. We all our laptops generally have flash memory now, but anyway, so we'll talk about that next time. thank you for watching today. And if you zipped to the end of this video, the first half of the video, Brad the TA explains about the forums and so on. So make sure you catch that beginning part.
Dr. Halverson, if I could say
Yes.
just a few things.
Yes, sure.
Before we ended there, we talked about the magnetic disk and it talked about the sectors and the different parts of a magnetic disk. And a lot of this stuff, guys, overlaps with different parts of computer science. So when you learn about operating systems too, you're going to learn about the same stuff in magnetic disks and how it's, how these resources interoperate with each other. So there's going to be some overlap here. You learn about this in databases, but you also learn about this in operating systems. So there's a sense of efficiency here, right? The more you learn, the more it begins to overlap. And I just wanted to say that as well. For those of you who haven't taken an operating systems class yet or plan to, there's going to be some overlap there. So.
Yeah, I think operating systems is a required course, isn't it? I noticed it's filled up for fall, so it's kind of nice when you get you see the same thing in another class. It kind of validates what you're learning. So anyway, all right. So thank you everybody for watching. I hope this helps. See you next time.